Hi class, this is a mini investigation that you can find in section 11.5 on page 609. So 609 of your textbooks, there is a mini investigation. We are actually going to do this investigation in Sketchpad, but notice there are going to be two conjectures that we are going to write after we do the investigation. So if you will open up Sketchpad, we are going to construct a right triangle. So I am going to just make 3 points there. I'm going to go to my pointer and I am going to construct a segment. Then I'm going to highlight that segment and a point and construct a perpendicular line. And then I'm going to make my right triangle. I have to have a perpendicular line first. So I'm going to go to my pointer and I'm going to find that intersection there. Then I'm going to highlight that point and construct a segment. Then I want to construct this segment. And that segment. So now I have a nice right triangle. I can hide the other things on there that I don't need, the other objects there, and I have my right triangle. Okay, so what I want to do now is make an altitude from the right angle to the hypotenuse. So I'm going to highlight this point and this line segment and say construct a perpendicular line, which will be the altitude. I want to find this point right there and then construct that segment and hide my line. So I have an altitude drawn from the right angle to the hypotenuse of my original right triangle. So now what I would like to do is measure some lengths and see what happens with that altitude from the right angle. Okay, so I'm going to have to construct this segment and this segment because I'm going to be measuring lots of different things here. Okay, so I'm going to measure the lengths of my original triangle. Oops. So there are the lengths of my original right triangle. I'm going to leave those right like that. And now I'm going to measure the lengths of this smaller right triangle. I'm just going to move those down a little bit. And then I'm going to measure the lengths of my third right triangle. And I'm going to scoot those down even further. Let's look at the ratio between all of the sides. So I am going to look at the hypotenuse of all three triangles and look at the ratio between the three. So I'm going to pull up my calculator, and the hypotenuse of my original big triangle is length AB. The hypotenuse of my second triangle right here is length BC. And then the hypotenuse of my third right triangle is length AC. So I am going to look at the ratio between AB and BC first. Oops, I need to say divided by BC and hit OK. I'm going to put this ratio up here. Now I'm going to look at the ratio between AB and the hypotenuse of my other right triangle, which is AC. And then I'm going to look at the third ratio between the two right triangles themselves. So I am going to do BC and AC. So we have three different ratios there, just looking at the different ratios between our hypoteni. Okay, so now what I want to do is look at some of the other ratios. So those were the hypotenuse, or the different ratios between the three triangles and their hypotenuses. So now I'm going to look at the other ones. So if you notice, they all have a shorter leg. So I am now going to look at the ratios between those. So I'm going to pull my calculator back up, and I'm going to say length BC, divided by BD, and hit OK. Look at that. It is in the same ratio as the hypotenuse. So I'm going to go ahead and stick with this triangle and go ahead and do the longer leg, which would be length AC. And I'm going to divide it by the length of the longer leg of this triangle, which will be DC. Well, guess what? It is in the same ratio. So now, what can we say about this big right triangle in relationship to this smaller right triangle? Because all three sides are in the same ratio, by side-side-side conjecture, we can say that they are similar. Do you think the same thing is going to happen with the big triangle and this other, the larger of the two right triangles? I believe it probably is, but let's check. So I'm going to pull up my calculator, and this time I am going to use the shorter leg, again first here, of the big triangle, and I'm going to divide it by the shorter leg of this triangle. Same ratio. So I have one more to check there. So I'm going to check the other leg, which is AC, or CA as it's written here, and divide it by the longer leg of this right triangle, which is going to be AD. So it appears that we have two similar triangles there. Let's see if the two triangles are similar to one another. Two smaller right triangles are similar to one another. So I'm going to pull up my calculator, and this time I will use the shorter leg BD and divide it by the shorter leg here, which is DC. Looking good so far. I have one more to do. So this time I want to check the longer leg. I've already done the hypotenuse. So I'm going to say DC and divide it by DA. So I have three right triangles. The big right triangle is similar to the smaller two right triangles, and then the smaller two right triangles are also similar to one another. So now you should be able to go back to your mini investigation and fill in the values and fill in the conjecture. And then I also want you to go ahead and figure out the answer to the second conjecture. I will take a picture of the screen so we can refer to it in class. We might want to go ahead and measure one more thing for the second conjecture. Let's measure some lengths, and then I'll allow you to come up with the conjecture on your own. So I'm going to measure BC, AC, and DC. And I think I already have, let's see, I already have all those lengths. I think I just need to measure DC is the one we don't have measured yet. Okay. So we already know that DC is in the same ratio as the lengths BC and AC. But how does it fit in with the length BD and DA? That's your last conjecture. See if you can come up with an answer, and we'll talk about it in class. See you tomorrow.